Hi everyone, in this video I thought I'd do a solar update. So the actual circuit itself has not really changed that much, although what I have done is I've wired them closer together, I've glued them in place, and I've just arranged it a bit better. The wires have actually changed. I'm using this solid core wire, but the schematics or whatever is just the same, the wiring's the same. What I have changed is this. Previously there was like a makeshift adapter board, breadboard converter, whatever you want to call it, and I plugged the SP into it, and I joined two pins together on a dip header piece thing, and yeah, I've changed that to a plate, an adapter plate. You can actually see the adapter plate being made in one of my previous videos, but anyway, so now I have a dip to screw terminal adapter plate, and it works a lot better, and the wires don't pull out, and it's just a far better job. So there are my microcontrollers and the relevant sensors there, and it works pretty well. So now moving on, here are the relays, and the microcontroller of course controls these relays. Actually, I say relays, they're not all relays. There's two transistors and one relay. So the two transistors control the two contactors. So one transistor powers one contactor and the other transistor powers the other contactor. And of course one's for solar to switch it on and one's for mains to switch that on. And the songle relay there, that's to switch the inverter on. I'm not going to go into the exact reasons why I've used two transistors and one relay, but suffice to say it works very well. So I was going to use an SSR, or a solid state relay, to turn the inverter on, and at one point I think I was saying how good the solid state relays are, but I noticed something that was quite important. And the solid state relay, for whatever reason, when I turned it on, the resistance was 8 ohms. And to have a resistance of 8 ohms when it's on, or supposed to be shorted, that's pretty poor, and I didn't like that, so then I went back to this songle relay. Okay, so the way this thing works is we have a mains connection, and mains comes into the system through here. So I've got a main switch, and that switches on or off the mains to my controller. So if you remember rightly, my controller can either choose mains or it can choose solar, and that depends on basically what the AI system does, how it controls the relays and stuff. So there's the isolator to terminate the mains supply from the controller, and then that goes to the contactor, of course, and all that. So that's where the mains comes in, and now if I just go over here, there's the contactor there. So the mains basically goes to one of those contactors. And solar, as you know, solar comes from the inverter here, and then from the inverter it goes up to this box here, and this has got RCDs in it. You can see that's actually an MCB and an RCD, and that's for safety reasons. But anyway, that goes from there, and that goes to the other contactor there. And then of course the relays, the transistors decide which one of those should be the source of power. And then the source of the power, after the AI controller has decided, the source of the power then becomes the output of the power and goes to this socket here. So just switch this off. That's the output. So this here, this socket, will either be solar or mains, depending on what the AI controller, which is there, decides. So what I'm going to show you now is I'm going to show you me manually messing about with this and choosing the power source. Okay, so the bulb is plugged in, and you know, if I turn it on you can see the bulb glow. So I need to put the bulb somewhere. I'm going to use this to show you that it's working on it. I'll put the bulb over here on this door here. It's not particularly elegant, but it will be okay. So now if I switch this on, the bulb comes on, and that's because this is the output of the whole system. Right, if I have a look over here now, you can see there are some buttons there. There's 4 buttons, 1, 2, 3 and 4. The first button controls whether the AI controller should be on or off. So the AI controller is the thing that I programmed in order to automatically decide whether the environment is right for solar to be on and the inverter to be on or off or whatever. This basically does all the decision making, and I can turn this on or off. So I'll turn the AI controller off. This now means that I'm in manual mode, and anything I do here will be done according to my instructions. If AI is on, it will ignore user input and decide for itself. Anyway, so this button here chooses the power source and it switches between the two. So if I hold this, it will change the power source from one to the other. And you can see there that it's switched over to solar. So it's switched over to solar and it's changed the contactor, but you can see that the light's gone off. And the reason why the light's gone off is because we've switched over to solar, but we're in manual mode and we have not turned the inverter on. So what I need to do is turn the inverter on. So if I go back over here, the button to turn the inverter on is this third button. So if I press that, the inverter should turn on. So just 1 second, you can see the remote controller thing here. So I'll turn it on and then the LEDs in this should glow. So now the inverter is on and the contactor is on solar too. Now if I just go back over here, now I can switch the inverter off or I could leave it on. It's up to me because I'm in manual mode. But what I will do, I'll use this button here to switch back over to mains. And now we're actually on mains. So this is mains power now. And to prove that to you, mains comes in here. So if I was to isolate mains, we should get a switch off. There you go. So now the contactor's on mains, but there's no mains power because I've switched it off. I'll turn it back on and we're back on mains. So yeah, that's kind of how it works. I've also got a shutdown. The fourth button is a shutdown button, which just shuts off the contactors and the inverters. Complete shutdown. So we've got the mains power up to this board, we've got the solar power up to this board, and then the AI controller here decides which should be powering, solar or mains. And additionally, it also has the ability to turn the inverter on and off. Now obviously, to use solar power you need the inverter on, but I think it's quite cool to be able to control both independently. That's why I've done it this way. Okay, so there's a better way of controlling solar, and this better way I created with ASP.NET and C#. I used SQL Server and a bit of networking, port forwarding, etc. And basically this website sends a message to the AI controller, which is the ESP32. Anyway, I thought I'd show you this. So over here you can see that the by the way, this is solar.atcbs.co.uk. That's only probably going to be a temporary domain name, but feel free to have a look around anyway. So it says connection status connected, and I've got various controls here. So by default, AI controller's on, and that's because of course I want the brain to make the decisions as to whether solar should be on or not. So if I switch the AI controller off, that means that I can then assume control over the power source and the inverter. So you can see here that these are not greyed out anymore, so I can decide. So let's switch over to solar. Now the light should go off. There you go, you heard the contactor, you heard the beep, and the light has gone off. I'm not sure if you've seen the light go off, but it has. But now, if I was to put the inverter on, the light will come on because we're in solar. And there you go, so the light's come on, and now it's refreshing. And there we go. Now of course in reality you wouldn't do that, you put the inverter on first and then switch over, because otherwise devices would black out for a second or whatever. But the AI controller does it properly. Basically what it'll do is it'll turn the inverter on and then 50 milliseconds later it switches the contactor. But anyway, just to demonstrate how it works, there's also the other button there, shutdown. That shuts down the two contactors, and it also shuts down the inverter. So I press that, you should hear a few beeps and everything's shut down. So now I'll put the AI controller back on because it's easier if I just let this brain do all the decision making. So that's the dashboard pretty much. I've got some current solar status bits and pieces like the amount of light, etc. Battery charge amount, which is 122, I think it says. That's overcharged, but that's okay. That's good because there's the equalise and the boost stage of charging lead acid batteries, so to be overcharged, that's okay. Then we've got maximum values and stuff like that. Battery within the past 24 hours, lots of different details. And then in the data log, that's just a raw dump, if you like, of data. It's like one record for every minute. And then in charts, yeah, I think I'll click in charts and show you. This sometimes takes a minute to load up. But yeah, the one I want to show you in particular is the light one. So there's light and it's measured in lux. And you can see that that's the amount of light for today. It's pretty poor really, but yeah, it is winter now, or is it? I don't know, November, so I think it is winter now. So yeah, that's the amount of light for today. So the AI controller would usually turn solar on if the amount of light is excessive of that yellow line. And there's one or two other parameters as well which involve the decision making. But anyway, that's the amount of light for today. So we've got command log. I'm not sure if you're going to be interested in this, but whatever. If the controller can't connect to the router or something like that, or there's no internet or whatever, there's a log here, so it says, you know, lost, found, etc. But this should be minimal really. See, it's been lost and found once today, and that was 10 o'clock in the morning for 20 seconds. So it looks like my internet connection dropped out for a couple of seconds or something like that. And then down here there should be a command log. Yeah, so they're the last 12 commands. And these commands can be from the AI controller itself. When AI decides something, it posts it to my server to log the command. It could be from the website as well, or it could be from the manual buttons. So we've got all these logs here of different things, and yeah, I programmed that to send off requests and then send a response back. So that's how that kind of works. And then I've got the how it works bit, which is something that's very new. It's something I did last week, and it's a written description of how everything works, including photos and stuff like that. So for those of you who are really interested in this, you can get more details. So anyway, this has been quite an informative update really, but I thought I'd show you. So yeah, there you go. Thank you for watching. Bye.